Hello everyone and welcome to Network Playroom. This is the 19th video in the Christmas calendar series, and in this video we'll discuss PGP message types. So let's get right to it. Now, all PGP message types have a common fixed-sized header, which is displayed on the screen here. And there may or may not be a data portion following the header depending on the message type. And the layout of these fields is shown on the screen here, as I mentioned. So let's look at each field individually. So first, there's the marker field, which is included for compatibility and must be all zeros. So that's really all there is to this field. It's all ones. And then there's the length field, which unsurprisingly indicates the total length of the message, including the header. So, total length. And then there's the type field, which indicates the type code of the message. Now, there are 4 different types. So PGP has 4 different message types. Number 1 is open. Number 2 is update. And number 3 is notification. And then number 4 is Keepalive. So you would see this number in the type field here. Oh, let me just write here that we were looking at the header. So let's actually start from the bottom of the list and discuss the Keepalive message first, because it actually consists of only the message header. So this is also the Keepalive message. So Keepalive messages are exchanged between peers often enough not to cause the whole timer to expire. And as a rule of thumb, the maximum time between Keepalive messages should be 1/3 of the hold time interval. And Keepalive messages must not be sent more often than every second. Now, Cisco devices have a default hold time of 180 seconds, so the default Keepalive interval is 60 seconds. Now, if the negotiated hold time interval is 0, then periodic Keepalive messages must not be sent. Okay, so let's move on to the next packet type, or PGP message type, which is the open message. Now, let me get rid of this layer and then hide the header and open this one. Now, after the TCP connection is established, the first message sent by each PGP speaker is an open message. And the open message contains the following fields as shown on the screen here. So this is an open message. So the version field here indicates the protocol version number, and the current PGP version number is 4. And BGP version 4. Oops. Now, the My Autonomous System field number indicates the autonomous system number of the sender. So next we have the hold time field, which indicates the sender's suggestion for the hold time value in seconds. So the PGP speaker chooses the smaller value from its configured hold time value and the received hold time value. And the hold time must be either 0 or at least 3 seconds. And the hold time value defines how much time can pass before a new update or Keepalive message must be received. Otherwise, the PGP session is torn down. So this hold time field is kind of dependent on or related to the Keepalive message. And this should not be less than 3 seconds. Now, the BGP identifier field indicates the BGP router ID of the sender. So this is the same concept as in other routing protocols. So this is to uniquely identify the router ID. And then there's the optional parameter length field, which indicates the total length of the optional parameters field. And if the value of this field is 0, no optional parameters are present. So we're looking at this field here. So if this is 0, there are no optional parameters. So if that was the case, then we wouldn't have the next field, which is the optional parameters field that contains a list of optional parameters. And they are encoded as parameter type, parameter length, and parameter value triplets. So it would look something like this. Parameter type, parameter length, and parameter value. Length. Did I type that right? I hope so. Parameter type, length, and value. Like this. Okay, but next let's look at the update message. So again, let me get rid of this. Close the open message and open the update one. Now here, the update message advertises any feasible routes, withdraws previously advertised routes, or can do both. So the update message includes the network layer reachability information that includes the prefix and associated BGP path attributes when advertising prefixes. But withdrawn NLRIs can include only the prefix. Now, an update message can also act as a Keepalive to reduce unnecessary traffic. So let's look at the fields. Oh, and here we're looking at the update, by the way. Update message. So the withdrawn routes length indicates the total length of withdrawn routes, and a value of 0 indicates that no routes are being withdrawn from service and that the withdrawn routes field is not present in this update. So this one. And again, it can be 0, so if 0, then there's no withdrawn routes. So then this field wouldn't exist or wouldn't be present. And the withdrawn routes field contains a list of IP address prefixes for the routes that are being withdrawn. And each route is encoded as length and prefix. Like this. And then next up is the total attribute length field, which indicates the total length of the path attributes field. And a value of 0 indicates that neither the network layer reachability information field nor the path attribute field is present in this update message. So this one. And this can also be 0. So if that is the case, if 0, then there is no NLRI or path attributes. No NLRI or PAs. Which is this field here, or these two fields. So let's look at path attributes first. which contains a list of path attributes for the routes being advertised, and each path attribute is encoded as attribute type, attribute length, and attribute value. So attribute type, attribute length, and then attribute value. So similar to what we had before with the other message type. Okay, and then finally, the network layer reachability information field contains a list of IP address prefixes, and the NLRI is encoded as length and prefix. So, like this field here. Okay, so let's move on to the last message type, which is the notification message. Again, let me hide these. There's a little bit more information here. We'll look at that shortly. So this is the notification message. Okay, so the notification message is sent when an error condition is detected and the PGP connection is closed immediately after it is sent. And possible causes include a hold timer expiring, the neighbor capabilities changing, or a PGP session reset being requested. Now the first field, the error code field, indicates the type of notification. So it can be any of these 6 error code types. And then the error subcode provides more specific information about the nature of the reported error. And there may be more than one error subcodes associated with the error code. And 0 can also be used to indicate an unspecified value. So in this field, you can have any of these subcodes. And of course, these are related to the major error code. So actually, as you can see here, this is number 1. And then number 2 here. And then number 3. And then the last field, the data field, is used to diagnose the reason for the notification, and the contents of the data field depend upon the error code and the error subcode. Right here. Okay, but now let's look at a packet capture to see these packet types in more detail. Okay, so I'm on packetlife.net again. And let's go to an open message first. So right here. So as you can see, here is the header. The marker is all 1s or all Fs in hexadecimal. Here's the length field, and the type of the packet is 1 because this is an open message. PGP version is 4. Here's the sender's autonomous system number, 65,300. The hold time is set to 180 seconds. And here's the PGP identifier or the router ID. And here are some parameters, optional parameters. So this is a capability. So again, here's the type, length, value. So this is multi-protocol extensions. So IP version 4 and unicast routing. I'm not gonna discuss this in more detail now. I just want to go over these fields and show you quickly. But yeah, that's the PGP open message. And then here is a Keepalive, so we should see only the BGP header, and that's correct. So here's again the marker field, which is all ones, the length, and the key message type is 4, which is the Keepalive message. Now next, let's look at an update message. So again, common header here, marker, length, type is update message, which is number 2. And here we have the withdrawn route section. So you can see that this route is actually being withdrawn. So it's a /32 prefix, and the network address is 172.16.0.4. And there's no path attributes attached to it. So this was the case, if this field was 0, then the other fields were missing. Okay, so let's look at another update message so we can see more of those fields. So here there are no withdrawn routes. And now you can see some path attributes. I will discuss these in another video, so let's just look at them briefly, but we don't have to care about the details at this time. So this is how they would be listed in the PGP message types, or in this PGP update message. So there's the origin, AS path, next hop, and so on. And now let's look at the network layer reachability information. So here you can see the different networks or the different routes being advertised. So this is a /24 network 10.30.3.0 and so on and so forth. So that's the update message. Now we need to go to another packet capture to look at the notification. So I have another one open here, again from packetlife.net. This one, notification. So let's open this up again. The common header, here's the marker field, length. This is type number 3, which is the notification message. And here you can first see the major error code, which says open message error, or number 2, and then minor error code says bad peer AS, and again it's code number 2. So I think what this means is that the neighbor is configured in the wrong AS, and that is why the PGP session is not being established. So let's see this list quickly on here. So we had code number 2, and here code number 2. Okay, but that's it about PGP message types. Thank you again for watching, and I'll see you in the next video.